Algebra 3, Chapter 7, Section 5, Multiple Angle and Product to Sum Formulas. In this section, we're going to look at four categories of trig identities. Functions of multiple angles, such as the sine of something times u or cosine of something times the angle. Squares of trigonometric functions, like sine squared of u. Functions of half angles, and products of trigonometric functions. Okay, our first set of formulas are our double angle formulas, and these are when you know the sine of u, but you need the sine of 2u. So these are the formulas that you'll use. These are power-reducing formulas. In other words, it takes a sine squared, cosine squared, or tangent squared, and it puts it into a formula that doesn't involve a power. And then half-angle formulas. This would be, say if you want to know what the sine of 15 degrees was. Well, you know the sine of 30 degrees. So you would say 15 is 30 over 2, and then you would put 30 into this formula. So that's how those work. The signs, the plus or minus, the signs will depend on the quadrant that the angle that you're trying to find the sine or cosine of lies. The product to sum formulas let you take the product of two trig functions, as you see here, and convert it to a non-product formula. And the sum to product lets you take the sum of two trig functions and convert it to a formula that multiplies things together. And these are all provided to you. You do not have to memorize them. You just need to be able to use exact solutions to the equations in this interval. How we're going to do that, we've got sine of 2x minus sine of x equals 0. What we're going to do is we're going to replace sine of 2x with its equivalent using the double angle formula. So as you can see here, I know I just brought up the answers for both, but sine of 2x becomes 2 sine x cosine x. Well, now we've got two terms that both have a sine in them, so we can factor that out and get sine of x times 2 cosine x minus 1 equals 0. Now we've got two factors, so we can set them each equal to 0 and solve, as you see here. For sine of 4x equals negative 2 sine 2x, what we did was we added it 2 sine 2x to both sides. You cannot combine them because the 4 and the 2 are attached to the x, not out in front, and they're not like terms. Then what we did was we converted the sine of 4x to 2 sine 2x cosine 2x. And we didn't mess with the other one, and the reason for that is now we have 2 sine 2x in both of these terms, so we can factor that out. And we get 2 sine 2x times cosine 2x plus 1 equals 0. We set each factor equal to 0, and again solve as we did before. Okay, now we're going to use a double angle formula to rewrite the expression. We've got 6 cosine squared x minus 3. What you're going to look at is look at your double angle formulas and find one where the right side of the expression looks very similar to what you see here. If you factor out a 3, you'll have 3 times 2 cosine squared x minus 1, and that may help. Pause the recording and see if you can find it, and then resume and we'll continue. So like I said, if you factor out the 3, you've got 2 cosine squared x minus 1. Well, that is the formula for cosine of 2x, so it's 3 cosine 2x. Now they want us to find the exact values of sine of 2u, cosine 2u, and tangent of 2u. We know the sine of u. We need to find anything else we need for the formula. So you're going to use the sine of 2u formula. And so the first thing that we're going to do is we're going to draw a triangle. And we're going to label it. The opposite will be negative 3, and the hypotenuse will be 5. We know the quadrant it's in because it tells us. And that will let us find the other information we need in order to use the formula. So the formula requires not only that we have the sine, which they gave us, but the cosine. Since we drew the triangle and labeled it, we know the cosine is 4/5. So we just put that information into it, and we get negative 24/25. We use that same information in the formula for cosine 2u to get 7/25. Tangent of 2u, you've got two choices. You can use the formula, as you see here, or you could say, well, tangent is sine over cosine, and do negative 24/25 divided by 7/25. Both ways will give you negative 24 over 7. Power reducing formula. And we need to think of a way to rewrite cosine to the 4th of x as cosine squared. And so what they did is they made it cosine squared times cosine squared. Once we have that, for each of those, we put in the power reducing formula, and then we multiply. And you'll notice we end up with 1 plus 2 cosine 2x plus cosine squared 2x. Well, we need to do the power reducing formula again on that one. So we do, and we end up with a fraction on top of a fraction. How we take care of that is we multiply top and bottom by 2, which gives us 2 plus 4 cosine 2x plus 1 plus cosine 4x over 8. Then we combined the like terms, which gave us 3 plus 4 cosine 2x plus cosine 4x over 8. And then what they did was they factored out the 1/8, which I honestly don't care if you do that or not. You can if you want to. Now we're going to use the half angle formula. What we need to remember is that 75 is half of 150. And we can figure out, we know from the unit circle and our triangles, we know the sine, cosine, and tangent of 150. So pause the recording, use 150 degrees for u, use the formulas, the half angle formulas, which would be the u over 2 formulas, and give these a try. Pause the recording and then resume when you're ready to look at the answer. Okay, so you see here how that works. We're putting in 150 for u, and then we're just putting in the cosine or the sine or whatever's required for the formula, and you see the answers here. Now, I am going to be very, very lenient about simplifying this, so you don't have to simplify it as far as they did. For example, for the sine, if you had 1 plus the square root of 3 over 2 over 2 and the square root over all of that, that's fine. You may leave it like that. I'm not going to really mess you up over having to oversimplify this, so we don't want to have to do that. All right, this time we need to figure out the quadrant that u over 2 lies in, and we also want the exact values of sine of u over 2, cosine of u over 2, and tangent of u over 2. All right, so what you want to do again is you want to create a triangle. It's going to be in the first quadrant, using the fact that the cosine is 7 over 25, find the missing side. Use the half angle formulas. We know that the angle, the original angle, is in the first quadrant. Well, if the original angle is in the first quadrant, half of that, what quadrant does half of that angle have to be in? It's kind of a common sense thing. So think about that. Pause the recording, give this a try, and resume to check your answer. Okay, so since the original angle is in quadrant 1, half of it has to be in quadrant 1 also. We didn't need to make the triangle for the first two because they gave us the cosine and that's what we needed. And then for the tangent, again, you can either do sine over cosine, 3/5 divided by 4/5, which is 3/4, or you can find the sine by making a triangle and then go ahead and solve it that way. Okay, we're going to use the half angle formula to simplify this expression. This is going to be the right-handed side of the formula, so you need to give me the left. Pause the recording and give it a try, and then resume to check your answer. Okay, so it's going to be the sine of 3x. It's normally the sine of 2x, but the x has a 6 in front of it, so cut that in half. And the second one, that should be 0 to 2 pi. Apparently I did not change the p to the Greek letter pi, but 0 to 2 pi, in other words, once around the circle, find all the solutions and graph to verify. So you're going to want to replace the sine of x over 2 with its equivalent in the formula. And this is going to be a little tricky, but pause it and give it a try on your own and then check your answer. So we replace sine of x over 2 with 1 minus cosine x over 2, and that's plus or minus, and that equals negative cosine x. Then we square both sides, set it equal to 0, get everything on one side. Well, multiply by 2 first, and then set it all equal to 0. Factor it out and find your solutions. Double check on the graph and notice that we actually do have some extraneous solutions. You can also check it by putting it in the original. X is pi over 3 and 5 pi over 3 are both extraneous. Pi is actually the only place where it touches down. The reason for the extraneous solutions is because we did have to square it in order to solve it, and doing that will often throw in some extraneous solutions. Now use the product to sum formula and the sum to product formulas on these and change them up. Pause the recording, give it a try, and resume to check your answer. And this is just a matter of plopping it right into the formula. So shouldn't be a huge deal there for both of these. Look over it, make sure you understand it. Just put the numbers, put the things right into the formulas. Simplify. Okay, same thing, but this time you actually have degrees, so you're going to evaluate the expression. And the one on the bottom, you're going to use our identities to solve. Pause the recording, give these a try, and resume to check your answer. Okay, same formula. This time we actually come up with angles that we know the sine and cosine of, so we're going to put the exact values in, and you should get square root of 6/2. For the bottom one, what we're going to do is we are going to replace these with formulas. Again, we're using the sum to product formulas here, and just doing a little simplifying. Okay, once we have it down to 2 sine 4x times cosine 2x, we can set the factors equal to 0 and solve. And there we go. And there's our graph. Okay, verifying the identity just means try to make the left and the right look the same using the identities we just had. We haven't done a lot with this, but think of it as a challenge. Pause the recording, give it a try, and resume to check your answer. Okay, cosecant theta over 2 cosine theta can be rewritten as 1 over 2 sine theta cosine theta, which can be split up into 1 over sine theta times 1 over 2 cosine theta. 1 over sine theta is cosecant, so cosecant over 2 cosine. And our other one, we can multiply out the left-hand side using FOIL. Then we can gather together the sine squared plus cosine squared, which equals 1. And then we also have the identity that 2 sine x cosine x is the same as sine of 2x.